Good morning, John. Today our topic is the theory of dilute solution. We are talking about the solution chapter, and now I will discuss about the theory of dilute solution. So, what is dilute solution? That means in which solution the amount of solute is very small. It can be very small for some solution, and it can vary. Okay? But dilute solution is the solution where the amount of solid will be very small, and they follow some pattern or trend that's called the theory. So the name is properties. First, and then I will explain. Sorry. Of Here it is. Lowering of vapor pressure. 2 is elevation of boiling point. 3 is depression in freezing point. And 4 is osmotic pressure. So all together, these 4 are called colligative properties, and this is the properties of dilute solution. So now question is that what is colligative properties? First of all, you see that colligative, that means it comes from colleague. Colleague means we know, like you are the batchmates. All the students of the same batch are called batchmates. That means this is the similarity that you are doing the same courses or same curriculum. Okay, you are following the same curriculum. That's why you are the batchmates. And here, colleague means whoever actually work together in job sector, they call colleague. In this case, they call colligative in together because all of these are related to each other by some property. That's why they are called colligative properties. So from this, I can ask you some question like that: why are they called colligative properties? Okay, why are they called colligative properties? So they are similar in some nature, physical or chemical nature, or in some parameter. So I will explain later step by step what is the similarities. Now let me define what is colligative properties. What is the definition? These all the colligative properties because they all are similar in to each other by some parameter or some properties. But definition is that the property which depends on the number of moles of the solute. We know solution means solute plus solvent. Solution means solute plus solvent. So the properties will depend on the solute moles number, not the physical or chemical property. What does it mean that by the physical or chemical property? It means that if I take sodium chloride as my solute, it's one kind of solute, and if I take glucose, that it's another type of solute. Their physical property and chemical property is different. Their chemical property is totally different. One is the inorganic product compound, another is the organic compound. Glucose, carbon and hydrogen element is there, but in case of salt it is sodium chloride. So that's the thing, that if I take sodium chloride, or if I take glucose, if I take sugar or any other different characteristic, like different types of chemical, it doesn't makes any influence in this behavior or in these properties. But if I take different types of solute, number of solute of sodium chloride, okay, if I take 1 mole of sodium chloride and another, if I take 2 mole of sodium chloride, then their behavior will be changed. This is what actually the colligative property define. That it never depends on the physical property, it depends on the number of moles of the solute. That means sodium chloride will not define their property. The number of moles, the concentration of the solution, that means the solute will, the moles number of solute will make some influence in their property. I think you understand. Okay?
Ma'am,
Yes?
can you repeat it again, please?
Yes. Colligative property is the property which depends on the number of moles of the solute. That means amount of particle, not on their chemical property. Chemical or physical property. That means if suppose I have two different container and I'm taking sorry, I'm taking 0.1 molar, right? And here I'm taking 2 molar. So amount will change their property. This amount will make influence in this property. But sodium chloride is an ionic compound. It will not, its physical property will not participate to define this property. Okay. That means if we change the number of moles, then their property will be changed. Okay.
Yes, ma'am.
So we understand if I give some example for each of these. So lowering of vapor pressure means lowering means decreasing, right? It is decreased. That means vapor pressure will be lowered somehow. So what is the vapor pressure? Some pressure that is created by the vapor, right? That is created by the vapor. Whenever we take some water to boil or to make some coffee or to make some another type of tea, like then it starts to boil, and the vapor is evolved from the whenever it starts to boil, right? At 100 degrees Celsius, it starts to boil, and then some vapor evolves. If I close the container, then some some vapor will be collected on the top surface, and it will be back to the liquid state. Or if it is open, it will be escape from the solution, and the volume of the solution solvent, that means water, will be decreased. Okay, I'm taking water, and I'm taking water plus rice. Okay, rice. So which one will boil first? Which one?
Only water.
Water.
Only
Water.
water. If I add more rice, it will be more slower to vaporize, right?
Yes, ma'am.
Yes, ma'am.
That means what does it mean that when I take pure solvent, the vapor will be more at 100 degrees Celsius or at so faster. But if I add some solid like the rice, okay, to cook, then it will take more time, right?
Yes,
To
ma'am.
reach 100 degrees Celsius. What does it mean? It means that it will take more time. It means that it will not vaporize so easily with respect to the pure solvent, pure water. So that's the thing, that vapor pressure is decreasing in case of rice plus water, right? So vapor pressure is decreasing by the solute particle I am adding in the water, and vice versa. In case of this, I said that it will take more time to boil for water plus rice. That means there to reach at 100 degrees Celsius, it will take more time. That means what does it indicate? That elevation of boiling point. Elevation of boiling point means temperature will recur more. That means boiling point will be shifted to another point because vapor pressure is decreasing. So I'll explain now. You see the first part, then you will understand. Okay? Suppose they are pure solvent. And I'm getting heat and the vapor pressure is evolving. This is the vapor, and by this vapor, some pressure will be created. Another is this pressure is denoted by P. Suppose it is P. Here, another part is but here suppose some solid particle. Solvent plus some solid. So non-volatile solid here. Suppose rice. Suppose rice or salt or any other non-volatile. So what about the vapor pressure for that? Small or
Very small.
less than this one?
Yes, ma'am.
Yes, ma'am.
Because here is molecule, solid molecule here. This will make some interaction which is not which will make some difficulties for this water solvent or for this solvent to vaporize. This solid particle will make some interaction with this molecule and it will not get vaporized easily, right? And it will need more energy. Energy means more temperature. That's why the first two property, that is vapor pressure, is lowering here and boiling point is increasing. That means temperature is increasing. You have to give more temperature, right?
Yes, ma'am.
So what can you relate it with a pressure cooker or cooking in the hill tracks? That in the pressure cooker, we need what does it mean? We need more or less temperature
Small amount of
to
temperature.
boil or to cook. And in hill tracks, it will because it is difficult to cook. It's related to the vapor pressure, and the temperature is related to vapor pressure. That's why they are colleagues. They are related to each other. So give me some definition. Give me the definition of boiling point. Do you know what is the boiling point definition?
Ma'am.
Tell me if you know. We know in general that whenever the solvent started to vaporize, started to boil, that is the boiling point.
Boy.
Yes, ma'am.
But it's the general thing. But in definition, you have to know that the boiling point is a point where the vapor pressure of the solvent is equal to the vapor atmospheric pressure. Okay, atmospheric pressure means 1 atmosphere. That means when the solvent will get the equal amount of pressure that is that presence in the atmosphere, then it will boil. And for different types of solvent, it is different. For water, it is 100. That means at 100 degree, it becomes equal to the environment. So if it doesn't become equal to the environment, will it vaporize? No, it will not
No.
vaporize because if it comes to another phase, one phase to another, they have to be homogeneous or they have to be similar. So at atmosphere, the vapor pressure is 1. So the molecule of the solvent should have 1 atmospheric pressure, and at which temperature they will gain 1 atmospheric pressure. That is the boiling point. So for this one, they will reach. They will reach to the boiling point easily because they will gain the 1 atmospheric pressure at 100 degrees Celsius if it is water solvent. But in this case, it will not reach 100 degrees Celsius. It will reach to 100 degrees Celsius, but at 100 degrees Celsius, we will not get the same amount of vapor like this because here some impurities present. Impurities means the solute is the impurities content. That's why here some elevation of boiling point occurred. Elevation means increasing, elevate hoa. Okay, elevate means increasing. So increasing of the temperature and as well the boiling point. So this is the thing here that if we take some solute, then the vapor pressure will be decreased. If I increase the solutes in this solution, whatever the thing happens,
Vapor pressure
be
increase
more
and
and more,
boiling point.
it will make more and more interfere to vaporize. That's why the colligative property is defined as that this property depends on the number of moles of the solute. Number of moles means how much particle present here, not on the chemical property, because here it's not about the chemical property, the size, shape, or ionic bond or chemical bonding. It's not about this. It's about the number of moles. That means number of particles present in the solution. So from this, if I say pressure is Vs, so which one is the greater one?
E.
theory, Raoult states a law that define the relative lowering of vapor pressure. So, how much pressure is decreased? How can we calculate? T minus. Okay, this suppose it is suppose X. I don't know what is the amount. Suppose X amount of pressure is decreased for that. So this pressure, how this pressure is decreased, on which it depends.
Solid.
In this solute, that means small number of this solute.
Yes.
Okay. So now Raoult says that the relative lowering of vapor pressure can you see? Can you see? Can you see? Can you see the board?
Yes, ma'am.
Yes, ma'am.
Okay. Raoult says that the relative lowering of vapor pressure. This is the lowering of vapor pressure, but he said relative lowering. Relative lowering means before it was P, after it was PS. So the difference, the ratio of the difference divided by P is the relative lowering. Okay. So this is the relative lowering. Okay. The ratio of the difference by the pressure, total pressure. Okay. Is equal to the mole fraction. So these changes depend on the solute, right? So how to define the solute? If I say the mole number of this is n and this is small n. So how to define the solute? The mole
Big N minus
number,
smaller.
mole fraction. Is it okay?
Yes, ma'am.
Yes, ma'am.
The definition of mole fraction, and if I say that this change is depend on the solute mole fraction of this solute, is it okay? Because yes, this change depends on the number of solute particle, and how to calculate the number of solute particle? We have to take the mole fraction of the solution, right? Mole fraction of solute. Mole fraction of solute is this is the mole number of solute. Mole number of solute. And this is the mole number of solvent, right? So total mole number of solute divided by total mole number of the solution is called the mole fraction of the solute. If I say mole fraction of solvent, so then what will be the equation?
Big N, no problem. Yes, ma'am.
Right? Mole number of solvent. The mole number of solvent. So now I will derive this equation. I will derive this equation using this theory. I will derive the Raoult's law that he said this statement. He gave this statement. So is it okay or not? We have to just establish the law, and he established this. Okay, Raoult's. That is called the Raoult's. So derivation. In case of derivation, we have to take in consideration this one. So P is for what? The vapor pressure of what? P is for what we get this pressure. Pressure for what? Solvent.
Solute.
Of course not solvent, because we calculate the pressure of solvent, but it is influenced solute.
Okay.
But basically, the pressure is for the solution, and solution means solvent, right?
Yes, ma'am.
So solute just makes some effect, that is, it increase the vapor pressure, nothing else.
Yes, ma'am.
But the pressure is for, we count for the solvent,
Solvent.
right? So the solvent vapor pressure is proportional with what?
Mole number.
Mole
That is the mole
Mole fraction.
fraction. So that is the mole fraction. So do you understand everything? Everyone understood this? How did I write this? That this is the vapor pressure of solvent, and the solvent vapor pressure is equal to the mole fraction of the
solution.
solvent. Solution means in solvent in solution. Okay.
So,
You have
yes,
to
ma'am.
tell like that. The solvent in the solution.
Solution.
Or if I say solute, solute in the solution.
Solution.
So this is the thing. So I can write this one as K by M plus M. So if I now what we are doing, we were doing that pure solvent and impure solvent. So we have to compare, right? Now we have to compare. So we have started from the impure solvent. Now we have to take in consideration this one. So in case of pure solvent, what will be the equation? If I say pure solvent, so in equation 1, what should be the thing?
Mole fraction 1 হবে
Right? So for pure solvent, for very dilute solution, N is negligible. For very dilute solution or for pure solvent, N is 0. That means no solid particle, right? Right.
Yes, ma'am.
Yes, ma'am.
So what will be the equation 1? For pure solvent, what was the pressure, vapor pressure sign?
P.
E is equal to K.
K N by N is to 1.
So this actually nothing. So I can write P equal to
K.
K. So now if I put this value in this vector to compare the pure and impure, then we can get some result. Like, so now put in this equation, P is equal to P, right?
Yes, ma'am.
N by
Yes, ma'am.
N plus
Plus.
S. And now it is, if I rearrange this, sorry, I can write here, P is by P equal to N by N plus A. So if I rearrange this, like 1 minus Px by P, 1 minus N plus N. Since we are making some mathematical calculation, we can make these types of rearrangement to do the final result. Okay.
Yes, ma'am.
So this actually is not nothing but some mathematical term. We have to this equation and this equation is same. Okay. So P is equal to A plus A here A plus A minus N. So ultimately you will have P minus P is by P equal to N by N plus N. Anyone have any question on this?
No, ma'am.
Still now, if anyone have any question or any confusion regarding this theory, you can ask me, because on the next class I'll go in deeper. So if you don't have the clear idea about this theory, then it will be difficult for you. So what about you, Irfan? Irfan, are you there? Irfan, are you there?
Yes, sir.
So now, can you tell me what is the application of this application? Why should we use this application, or why should we know this theory? Can you imagine any guesses? Any guesses?
ম্যাডাম ভয়েসটা ক্লিয়ারলি বোঝা যাচ্ছে না।
What is the application of this equation? Any guess? No idea.
And to
I have
calculate the
said
vapor
that
pressure.
this is for non-volatile solvent. So protein is not volatile or volatile?
Colloidal.
Volatile. DNA, RNA, like it is it volatile or not?
Ma'am, they are not volatile.
Volatile means udai, yeah,
Right.
উড়ে যায়,
Iodine.
biological compound. Okay. Non-volatile. So most of the biological element is not volatile. So if you use this technique, on the basis of this technique, we can identify the molar mass of the non-volatile compound. How? You know, here is the number of mole, and from n equal to what? How can you calculate the mole? From the mass, molar mass, n equal to what? Mole equal to what?
C by V.
Molecular weight divided by weight,
Yes, ma'am.
right? Molar mass divided by weight. So we'll take 10 gram of, suppose we are taking 10 gram of protein, any types of protein or any types of non-volatile sample. So then we know the weight and we know the mole. That means we know the sample name, that it is amino acid, it is glucose, it is sodium chloride, that's all. But we don't know about the, suppose we don't know about the name also, we just know the amount we are taking, 10 amount. So from the 10 gram, so from the gram, can we calculate the molar mass?
No, ma'am.
So solid is mass by weight. So we know the weight 10 gram. So we can calculate the mass, but how?
We need more সংখ্যা।
Other part of it, right? So you use this equation. Get open it this equation to know the molar mass. This is the application. To know the molar mass of unknown solid that is not known to you. That what is the weight, molecular mass of the sample? What is the solute actually we are using? So you can identify the molar mass, then you can predict that maybe it is that solid. And then further any further what does it say that further analysis you can get the sure or the original name of the sample. You can make sure. Okay. So now I'm going to the application of that. One of the application, not this is one of the application. So there are lots of application. You have to know the application behind this. All the theory or derivation, all the equation have some application in practical life. So I'm giving you the idea about your subject related application. So most of the biological compound is non-volatile, and you can use these types of technique to know their molar mass. The question can be arise like that. How can you know, how can you determine the molar mass from by using the Raoult law or by using the lowering of vapor pressure? So you have to explain this one, and finally you have to complete by this. N equal to M by W. It is capital, that's a capital L plus M by W. So I have said that if I consider it is very dilute solid, then this part can be negligible. This part means this one, solid part. Okay, suppose this is very negligible. So, put much in this equation or not?
বুঝলাম না
Slightly, it's not. It can be. It will be actually almost similar, right? So you can omit this part finally for simplification. Nothing else. We use always a simplified equation to determine to solve the mathematical problem. So for very dilute solution, we can omit this part. C minus B by P M by W divided by M by part is for solution. So with respect to solution, it is negligible, but not upper part. Okay.
Yes, ma'am.
নিচের পার্টটা কিন্তু আমি negligible করতে পারি with respect to the solvent. Because suppose I have 10 liter of water, but I have only 0.00001 milligram of solid. So that's the thing that in that case it is almost negligible and it will not give any change in this equation. So finally we can write this as P minus P is divided by P equals to the final equation from which you can calculate the molar mass of an unknown solid by using the lowering of vapor pressure. That means this is an experiment. You can use this as an experiment where you will measure the pressure, you will measure the vapor pressure for two solvent. One is pure, another is with solute. Then you will use the equation. Then you can find out the molar mass. Like V1 S1 equal to V2 S2 is established. That is also established. But in this case, we'll find out the molecular weight. That is molar mass of the solute that is in the solution. We experimental setup, that is Oswald, maybe it's named by Oswald method to determine the molar mass by using vapor pressure. So you can see in the reference book to know about that experiment, but I'll not suggest to memorize that process. That's the only experimental part you can go through, because you may have to use this process, maybe or not, but if you go through, you can get some idea, practical idea. Okay, in your reference book, in the essentials of physical chemistry, you will get this experimental procedure for that theory. Okay, so that's
Yes,
all
ma'am.
for today's class. I'll explain the rest of the three on the next class. Yes,
Ma'am, regarding